Problem 5. At what temperature will the diffusion coefficient for the diffusion of copper in nickel have a value of 6.5 into 10 to the power minus 17 meters square per second? Use the diffusion data in table 5.2. So in this case we have been asked to find the temperature. For diffusion coefficient, we know that diffusion coefficient is equal to diffusion pre-exponent multiplied by the exponent of minus activation energy QD over KT, where K is the gas constant, T is the temperature. So the diffusion coefficient value has been given 6.5 into 10 to the power minus 17, and diffusion pre-exponent value we can find from this table. So for this table gives you the values for different combinations. So here it is said that copper in nickel. So copper in nickel should be in the interdiffusion category. So copper is here and copper in nickel. Okay, the host metal is nickel and copper is the diffusing species, copper in nickel. So the values are 2.7 into 10 to the power minus 5. So D naught is 2.7 into 10 to the power minus 5, and then the exponent minus this QD, which is the activation energy. We can also see from here 256,000 joules. So 256,000 joules divided by the gas constant, which is 8.31 into 10 to the power minus 5, and the temperature, which is the one we need to find out. So now it is up to you to solve it, and if you will solve it by some calculations, the answer will be so the answer over here will be 1152 Kelvin, or you can convert it into centigrade as well. Okay, so the same problem can be solved by using the VMSE. Okay, VMSE, which is Virtual Material Science and Engineering. It is a web page by Wiley. So if you go to that web, so this is the web page of Virtual Material Science and Engineering, which you can search from the internet, and you on this web page you click the diffusion part, and under the diffusion part the first module, D versus the 1 over T plot. And in this D over versus 1 over T plot, first of all you will select this for our current problem, which is copper in nickel. So if you select copper in nickel over here, you can see that automatically these values for the diffusion pre-exponent and activation energies have been pre-filled. So you can see that these are the same values which you got from the table. Now you will click add curve, and the plot of diffusion versus the temperature is shown over here. So on this curve you will find the value of the diffusion coefficient. So remember that the diffusion coefficient was 6.5 into 10 to the power minus 17. So go back to the Wiley VMSE, and then if you scroll around this curve, so you will see that you will see this dot, and on this above this dot you will see in this box the values. So the topmost value is showing you the temperature, and over here you will also see the value for the diffusion coefficient. So at this point we can see that the temperature shown is 1202 Kelvin, but the diffusion value is 1.94 into 10 to the power minus 16. So the required diffusion value for this problem is 6.5 into 10 to the power minus 17. So I will move this point along this curve until I get that value. So here I am moving down, so it is 8.84 into 10 to the power minus 17. So it will be over here 67.33 into 10 to the power minus 17. I go one more point, 6.88, it's closer, and next point is 6.45. so this is the closest. So for this 6.45 into 10 to the power minus 17, you can see a temperature value of 1153 Kelvin. So you can record this value 1153, 1153. So as you can see that our answer was 1152 Kelvin. So this, from this VMSC, you can see that the value is equal to 1153, so which is quite close. So this problem can also be solved by the VMSC web page as well.